Hello, this is the only thing that you're going to hear from me in the next few days because I'm going to be out on Thursday and Friday, so we don't have new homework until this coming Monday. Please do definitely look through what you know about proportional relationships and equations, and also start looking back at your old blueprints and practice sheets to prepare yourself for your midterm next Tuesday on October 24th. Okay, so looking at this, we've got our practice check. And the goal here is to end up with an equation that you can use to solve for more complex numbers or numbers that aren't in the table, such as in number 3, what could you do if you had 24 hours? So looking at this, I see that after 2 hours, 4 inches of snow have fallen in Syracuse. That's in the table at the 2-4 row. And I need to start looking for ways that I can scale it. So if I go from 2 to 1, that would be scaling down divided by 2. So I would do the same on the inches side, 4 to 2 inches. So in 1 hour, I can go 2, or I'm going to have 2 inches fall. That's a unit rate right there, 2 inches per hour. If I wanted to get the other unit rate, though, how much time would it take to snow 1 inch? Then I could go from 2 to 1, which would be divided by 2, and 1 divided by 2 on the other side would be 1/2. So now I notice, as I'm looking at all of these rows, that to get from time to snow, I'm doubling. A 1/2 inch to 1 inch times 2, 1 times 2 is 2, 2 times 2 is 4. So I can continue multiplying by 2. That means that in 6.5 hours, we could expect 13 inches, because that would be 6.5 times 2. And after x hours, we could take that number of hours x and multiply that by 2. When I say 2x, I am not saying 2 times, I am saying 2 times x specifically. So we've got our 13 inches of snow. Now an equation, I'm going to use the generalization that we have for x hours. If I do 2x, that's going to give me the amount of snow. This is an equation, it uses an equal sign, it tells me what two quantities are going to be balanced here. So then I can plug in new information, like in 24 hours, I can plug that into my equation. 24 hours times 2, I'm going to have the snow fall to 48 inches. Okay, so here I have everything laid out. I'm going to walk through what we see. In red, across the board, that's related to the constant of proportionality. That is, what is it that is happening at every row of this table? If there's something that's constant across every row, then we have a proportional relationship, and that constant would be our constant of proportionality. Everything on the right side is here in blue, so that we can, when we get down to our equations, kind of see the difference between what's on the left side and what's on the right side. Going from meters to millimeters, going from a larger unit to a smaller unit, we're going to need a lot of millimeters. People noticed that we needed to multiply by 1,000. That meant that our constant of proportionality was 1,000. On the other hand, when we were going from millimeters, which are small, to meters, which are large, we're going to need a lot fewer meters. So we are going down rather than going up. 1,000 divided by 1,000 would get me 1. For the constant of proportionality, I want to be multiplying, so dividing by 1,000 is the same as multiplying by its reciprocal, 1 over 1,000. Now paying attention to the equations below, I kept everything on the left black. I'm finding that I take that length in meters, I multiply by that by 1,000, and I get, on the other hand, or on the other side, by length in millimeters, which we have here represented in blue. So the equation for the relationship would be starting with meters, multiplying it by 1,000, and then on the other side, after applying our rule, we get millimeters. And that's how I developed that equation. On the right side, if you start with your millimeters, you're going to divide by 1,000 to get the number of meters, which is the first equation that I have. And then if I wanted to rewrite that as multiplication, millimeters divided by 1,000 is the same as millimeters times 1 over 1,000. You also could put x in for meters, since that was a variable that we had defined for us in the table. You also could put y in for millimeters, since that was something that we had defined in the table. I just wanted to be clear about meters and millimeters here, since this is new to lots of people. All right. Now, with this situation, what was challenging was that you were asked to go straight from a scenario, a verbal scenario, to equations. And people were a lot more successful when they considered, when they considered how they could use a data table to organize their data. Looking at the information here, we know that it takes Andrew 5 minutes to fill the tower garden with 8 gallons of water. So I made myself a table and I put the 5 minutes to 8 gallons in that table. And if I played with it a little bit, I can see that if I scale up by 2, in 10 minutes I would fill 16 gallons of water. But that doesn't yet get me to an equation. It would be helpful for me to find a unit rate because that's going to give me an idea of what I might need to multiply the gallons and what I might need to multiply the minutes by. So I'm going to look for first the unit rate of 1 minute. So to get from the 5 to the 1, 5 minutes to 1 minute, I would need to scale down by 5 divided by 5. And on the water side, that would be the same. So then I would have 8 divided by 5, or 1.6. That unit rate is the unit rate of 1.6 gallons filling in 1 minute. Now if I look at my table, if I take time, multiply it by 1.6, then I'm going to get gallons, because 1 times 1.6 is 1.6, 5 times 1.6 is 8. Which of the equations on the left side also shows starting with time and multiplying it by 1.6? This is the only one where you have time in minutes multiplied by 1.6 to get gallons. Yes, the order is reversed, but that does not matter when you're multiplying, just as it does not matter if you're just saying if you're just flipping what's on either side of an equal sign. So that's for the unit rate of 1 minute. But what about the unit rate of 1 gallon? Okay, so looking at this, instead of getting down to 1 from 5, we're trying to get down to 1 from 8. So 8 divided by 8 would get me 1, which means that on the left side with time, I would do 5 divided by 8, which would give me a unit rate of 0.625. 0.625 is the minutes, 1 is the gallons, so that means 1 gallon fills in 0.625 minutes. And then if I start with gallons and multiply that by 0.625, then I get minutes. And which of the equations over on the left side shows starting with gallons and multiplying by 0.625? Only D does, because that is the only one where I have my gallons of water, represented by W, being multiplied by 0.625. In your homework tonight, I want you to consider 1, what relationships do you see happening across the table? And 2, how can you express the direction of the things that you see happening? That's going to be helpful when you're setting up an equation. So for example, when we have 1,000 meters, we can divide that by 1,000 to get the 1 kilometer. When we have 3,500 meters, then we should be able to do the same thing and divide by 1,000 to get the number of kilometers there. We could generalize that to say that for any number of meters, if we divide it by 1,000, we will get the number of kilometers that represents. If I'm writing an equation for that then, I need to think about if I know that I need to end up with kilometers, what can I do to get 2 kilometers from meters? And you're being asked to use X for the number of meters and Y for the number of kilometers. I hope you have a good end to the week. I know that you're going to do some solid work with equations and with proportional relationships, and I'm looking forward to coming back and revisiting this with you on Monday.